real quick, just go through a bunch of things, and then so I'm showing you the front end, which I host through Apache, and then I'll also show you back end, which is on Linux in the cloud, as well as on a laptop that I have right here. Right, so this laptop is able to essentially now send any of these images that you see. You can load money onto it and whatnot, and actually, I'll access the laptop remotely from the computer. But I just want to go through real quick, and so and I'm going to get rid of this little window here because it's not super helpful. All right, so what we have here is this is a project that I'm currently working on, and what we do is look at every single block in the Satoshi Vision ledger as it pops up, and to give you a sense of what Satoshi Vision is versus other currencies, we can look here. Right, so here's Bitcoin, the Bitcoin that everybody loves and hates. There's Ethereum. These, I find that even though people get very excited about trading these, I find them almost completely useless. Look, it's up 15% because they're just very difficult. I have no idea. Binance Coin, Cardano, Tether, right? These are all things that you've probably heard about. But then you come down here and you have, for example, Litecoin. Litecoin is a fork of Bitcoin, which uses the same numbering scheme, the same name scheme, which is to say they both generally, the addresses start with 1 or 2 or something like that. Usually they start with 1, most addresses. And then some of these are tokens, right? Here's Dogecoin, which is another fork. And these are the ones that I will use. I find these much more useful. The forks of Bitcoin versus something that's built with an Ethereum smart contract or something like that, right? Because what happens is things are done on your behalf, and identity gets kind of muddled in these solutions, and then you also end up with things like $15 transaction fees. So Satoshi Vision is there it is. There's Satoshi Vision, and then Bitcoin Cash should be around here somewhere too. So Satoshi Vision is unique in that they've lifted some soft limits that were put in place in Bitcoin to limit the ability to use this as a data system, which is exactly what Ethereum is, right? So you can look at Ethereum as a response to the fact that Bitcoin itself had these limits placed on it. But this Bitcoin, there's Bitcoin Cash, it's 11. So Bitcoin Cash, to some degree, increased this size. It's a size limit. So they increased it to make it more useful. And I'll show you that in a second. Bitcoin SV completely removed this limit, which again is an artificial thing added to the system. And and as you'll see, it functions very differently. Okay, so each of these represents a Bitcoin Cash transaction that I found that happens to have data in it. And let's see. So if we just we'll open one, then what I just did there was I went and looked at my local copy of the ledger, which I'm running, and pulled up that transaction, found an image in it, and constructed the image all in a few seconds. It's a JPEG. Here it is. And this is a link to what's on chain, so you can also see the same information provided by a third party. Um, this is a block explorer, they call it, and it's a special purpose block explorer because, as you can see, here's your input. So funds were sent from this address to these two addresses, and a zero fund transaction was also sent, which is what we see here, which is number 3, the third output. And that is the image. So uh, previously I was saying that one of the techniques to embed data in here is to begin actually with a Bitcoin address, and that is used to signify the format. And it's kind of an ingenious way to do that because the owner of that address can sign things, right? Can verify that indeed they're the owner, and so it's a very nice way for them to uh, uh, maintain the protocol, and the protocols can be very simple, right? Like this is, in fact, I don't even really. I'm just beginning to read the protocols. Usually, I just look at these, find large transactions, and and decode them. This technology is called op return, right? So there's different operations, and op return is simply the operation to uh, return to the code, and then there's just this is sort of like a comment, you can imagine, a very large comment that's stuck in the middle of the system. It doesn't affect any of the processing of any of this. It's just literally data. There's a nice decode button here that they give, and you'll see the same information there that I had. It decodes the image, and so that's how that works. And each of these is 1,000 blocks. Each block has a number of transactions, and some of the transactions will have this data embedded in it, and the data can even be, as we see here, and I create some of this, MP4s, movies, you name it. There's all sorts of data. And in fact, this is a filter that I've been working on, and this only shows SVG data, which I know is something that's important for this project. So if we look at what's on chain for one of these, we'll see the SVG. Again, there it is. And actually, this address is slightly different, I believe, in this one. And you see, so there's XML, right, embedded right in there, and that's and again, you can hit the decode button and it will decode it. And because this is shared information, there's many different places where you see people pulling this information out. And then this is it's just an image. So this is from a GUI that I built to load information in. This is part of the process. I loaded this image up from my computer, and then I transform it. And it's not a particularly difficult transformation into this format. This 006A is the code for op return codes. This is one of those address formats that I just put that in so that this what's on chain site will recognize it. However, you don't have to do that, right? You can just simply put the image in hex format, and and then there's I break things down and make it a little easier to understand. So there's this is as if I'd hit the fund button, and if I hit that, it will write this to the ledger, and this is the fee that it will cost. I have about $50 right now loaded onto this server, put this stuff out there, and Matt does that too. Now, so this is the sort of thing that I find interesting to put in. This is the wildly racist Dr. Seuss propaganda that folks have forgotten about. And so this is one of the things that obviously is gone out of print. So I put that on there. And what I'm showing you here, when it says previous transaction, this is linked to the transaction before. And if you look at the transaction before, this is one that Matt put in. So we kind of alternate. We're sharing the address. And if you keep going back, you see this is one that he sent from his phone. Or maybe I sent this from the phone. Yeah, to show that to send a very tiny amount of Ethereum, there's a $3 transaction fee. So it's kind of a joke for me. I took a picture of that and uploaded the entire image into the system for less than the $3 fee that this transaction would have had going from my phone, literally just sending less than less than a penny. And so we could go back. Now here's a QR code, and adding QR codes is interesting because you can. This goes to IPFS. You can link. You can send just an image that someone who is doing something similar to this will see the image, and the QR code will be in there. See, there's another QR code somebody else put. And somewhere in here you should see my QR code in through all this stuff. It is possible to find our own transactions in here somewhere, but we have other ways that are a little bit easier to show that. And again, more. Now, so that's the new way I do things. The old way I used to do things can be combined with this, and in fact, if Satoshi Vision suddenly changes and puts this artificial restriction back in place so that you can no longer embed these images into the chain for whatever reason, then immediately I can use my old solution, which here's an example of this. I'm not even using the op return code field here at all. I create these dummy addresses and put the data into the address field, which is another scheme. It's a hack. The money sent to that never gets resolved, and so it is problematic. However, if you want to communicate at all costs, then that's what you do. The IPFS address is embedded in these two parts here. So that QM capital P up to the little z's, if you take that part out and that part out, and you put it in IPFS, you will see that. And let's just do that just to kind of show you. I'm going to pull a screen over here. So this is kind of backstage at the thing. So if I copy and paste that, I can very quickly derive the IPFS address from this. There's one that's DD. This one is DE. So then the address would be this part right here, and it's a certain length, and it's right before the two little z's, and this is just a very simple. It's almost not encrypted, right? the nice thing about this is you can do this from your phone. You could even you can't send multiple lines from your phone, but as we've seen before, uh, because one transaction feeds into a next, you do have the tree leaf structure. So you could see this record, that record, and that as three different transactions. You could paste them all together and come up with this. And then let's see. And this is what I was doing on my old site. However, it's really interesting because you can do it from here. And oh no, it says it's invalid. So I messed it up somewhere. I missed something. Had I done that right, let's see. You would see something that works. Oh, that's a tar file that I put in there. Anyways, I'm not going to spend any more time on that. This is from the laptop I showed you before, and this is just showing that it's a current version of the ledger. That's the block 6677684. That should be relatively current block. Once this is a completely current, like I say, you can send and receive transactions right from this machine. And so basically I offer two options. One is to build out the whole thing like this. It takes about half a terabyte of space for the entire ledger. And then one is just to build the ability to send. This piece right here that lets you send. And then so this is the back end, and this is of course this is a Linux back end, and I'm just showing here that there is a command, and so what I'm trying to demonstrate here. Let's go back. I wonder what I missed there. If you go back here, so this address is one that we should be able to recognize here, right here. Okay, so this is an address that I own on this server. It's associated with this server that building the images, and just like I was showing that you could see all of the images locally that are connected to each other, you can see the same thing here. Now, not everybody does it this way, and that's a problem. As people try to build solutions that make it easier for on-ramps, sometimes the data gets lost, and so that's the big challenge. The core technology works perfectly, but it's the on-ramps and off-ramps and integration with other things, which you have to integrate with kind of the world before this, and that's where a lot of the challenge comes in. It is not difficult to operate in this. I don't need special stuff. It's very easy, very elegant. The issues all come in integrating this to the outside world, and I have a number of ways to do that with paper wallets and phones and servers like this laptop that I showed you earlier. And so, yeah, so that's just a silly image that I saw. This anyway, the point here is that this is me, and from this server right here, you see I'm going to sign the message with that address. So I'm saying use the private key of that address, which we don't see here. And then there's the message, and then this is the signed message. It often ends in zero, or in that minus equal sign. So then if you come over to here to this, you can say verify message. Now this server doesn't have the private key to this address, so this server can't sign a message from this. This is core, fundamental to the way that the ledger works. In addition to signing messages, you use this to sign the transaction, which is one of the steps up here that I had done, sign transaction. So you see, now to verify it, anybody does this. This is what the miners do to prove that you are in fact who you say you are, and then they will update the ledger on your behalf. And everybody can see that they're doing so because you were able to sign the message, and they verified that. There's the address. There is the here's the signature string, and then so if you know the address, the signature string, and the message, you put them all together, and this is able to see it says true. So that's saying that to change it when that's false. It has to be the exact message. So this sign verify process is fundamental to how everything works. And here's an example here just of the alternate way to do things that I had devised before, giving you a level of incredible fault tolerance, because if one thing within the system is changed, which again, the system works perfectly until outside variables come to play, and those generally would happen because of regulations, because people aren't comfortable with things that they can't control, and this is very much an out of control system. Again, because from my laptop I can send an image into the system. You can eventually figure out my identity, but if I'm a miner and I create new currency and then use the new currency to create an image, then I don't know how you're going to even understand who I am. So it's a very, very powerful system. And that's just a brief overview.